Today we're going to continue on with our trig functions. We're going to be looking at angles that are larger than 90 degrees or potentially some negative angles and how we deal with those. So first we're going to just start by figuring out sine of 210 on our calculator, making sure our calculator is in degree mode. You just type sine 210 and we get that this is equal to negative 0.5. All right, so we have some issues. When we have these sine, cosine, tangent, we talked about this the other day, all of these are coming from these right triangles. So how in the world do we have a right triangle with an angle of 210 degrees? And a right triangle, any triangle, all the angles have to add up to 180, and so you can't have this angle of 210. So how do we deal with that? You would have talked about this a little bit last year in Algebra 2. This is where that graphing, those angles come in, and we look at 210 and what triangle it makes in another quadrant. And then the reason why this ratio is negative is because those triangles are now going to be in these different quadrants. So these vertical and horizontal legs or lengths would now be going in negative direction. So we're going to look at what happens when we graph our angle 210. So standard position, remember we have it starting on that positive x-axis here. And we want to open it up to 210. So if I put in my little touch points, I've got 90 degrees at the top, 180 due west, 270 south, and I'd go all the way back around to 360 at that starting point. So 210 is between the 180 and the 270. And it is going to be a little bit closer to that 180 than it is to the 270. So, but this is my angle here. It is larger than that 180 degrees. It opens all the way up to that 210 down in the third quadrant here. And so what we want to do is we want to create what we call a reference triangle. If I were to draw in this vertical line here, we've now created a right triangle that's below the x-axis here, and we can have something called a reference angle. So that 210 degrees is larger than the 180. It is 30 degrees larger, which means just from the negative x-axis right here, we have a 30-degree angle. So while the entire angle there is 210, just to the x-axis, it's a 30 degrees. So we would say we have a 30-degree reference angle inside this reference triangle. And then we can create or build these side lengths for that special right triangle in this new reference triangle. So special right triangles across from the 30 is a 1, hypotenuse is 2, last leg there is root 3, and all we have to do now is put in these directional signs. When you move from the origin here, if we move to the left like we have on that horizontal distance, that's typically the negative. So we would say that this has a length of root 3, but it's in the negative direction, so it's negative root 3. And if we move down, that's also a negative sign. So while that vertical leg has a length of 1, because it's going in the negative direction, because it's going down, we would say negative 1. So that sine of 210, I would look at my reference triangle, and I've got my angle here, and I would say, well, sine is opposite over hypotenuse. So opposite the reference angle is negative 1, and my hypotenuse is 2, and I get that negative 1/2, which is that negative 0.5 that we got on our calculators. All right, so hopefully this is somewhat familiar to you. If not, we're going to do a couple more to practice here. But what we're trying to do here is we're creating these reference triangles, these reference angles. So we graph the angle. This angle is something like maybe 120 degrees. But we want to draw in that reference triangle. So we always do that by drawing in the vertical leg. So we always want to go vertical. So if we're down below, we would draw up to that x-axis. Or here we draw down to that x-axis. So we always want these to be vertical legs we draw in. And what we're going to do is we are going to put in our reference angles so that we can figure out what these side lengths are. Or if I know my side lengths, fill in our side lengths and then try and figure out which of those special 30, 60, or 45 degree angles we're dealing with, what sort of special triangle we have. Now the thing with the lengths is we need to be careful about when we have negatives. So we're going to include some negative lengths. Now lengths technically are never going to be negative. Just like with negative angle values, it's all about a direction. So if you're at that origin, if I'm going down to the left, okay, that's going to be a negative value. So this length here, this would be negative. But if I'm going up, that's a positive. So this one here, that would be a positive length. And then our reference angle, they're always the angles that are inside these triangles. So they're always going to be these acute angles like 30 degrees, 45 degrees, 60 degrees. All of them, they're all going to be angles that fit inside of these different right triangles. All right, so we're going to do it with 120 degrees. We're going to draw in the 120 first. And we're going to create a reference triangle, and we're going to figure out what our reference angle is. All right, so that's all we're going to do right here. So we're going to start with that standard position. So we're going to draw in that positive x-axis line, positive x-axis, that initial side. And then, again, I got my 90 at the north, 180 at the west, and 120 is between them. And it is closer to 90 than it is to the 180. So it's going to look something like this. And we can draw this in here. This is my 120 degrees. Now when I draw in my reference triangle, remember we always want to draw that vertical line in. So there's my vertical line. And my reference angle is going to be inside the triangle. So this is my angle here that I'm trying to find. That's not the 120. The 120 is the angle in red, but I'm looking for the angle inside the triangle. So my reference angle here is going to be whatever's left over for that 120 to make it to 180, to make it to that horizontal. All right, so converting this, we get our radians, 3 pi over 4 radians becomes 135 degrees. You can do that. You can convert it into degrees and then draw it and do what we were doing right just before. Or you can keep it in your radians and do all of your touch points in radians. So go ahead and try it and come back and we can check our answers. All right, so here we have actually that exact same triangle. Negative 225 and 135 are coterminal angles. So we end up with the exact same ending position, and we end up with the exact same reference angles and the exact same reference triangles. So the big difference is we started off with radians, so we do need to answer the final question in radians. So we'd say that our reference angle, we could start with the 45 degrees, but then we do want to convert back to radians and say it is pi over 4 radians. The triangle is the same. Whether or not we use 45 degrees or pi over 4 radians, the triangle is the same. That horizontal distance there, because we're moving to the left, it's negative. The vertical distance is a positive because it's moving up. And then the hypotenuse is always positive for all of these triangles. All right, one more. We have the 11 pi over 6. This one's not going to match one of the ones we already did. Go ahead. You can pause the video. Try and do this one. You can convert this if you want. You don't have to, but you definitely can. It might make things a little bit easier for you. All right, so if we convert this to degrees, we get 330 degrees, which is a large angle. It is almost a full revolution. Not quite. But it's going to be in that fourth quadrant, closer to that horizontal, that x-axis than it is to the vertical axis, closer to the 360 than it is to the 270. So we draw that in to figure out what's left over. We could do 360 minus 330, and that gives me the 30 degrees inside the triangle. And I can fill in, okay, what's the 30, 60, 90 triangle? So that means that opposite leg, that vertical leg, is going to be the 1, but because it's below the x-axis, because we're going down, it's a -1. And then that horizontal leg, that's positive because we're to the right of the origin. So that's our positive √3. So we've got our triangle here, just like the last problem. The reference angle is going to be 30 degrees, but because we started in radians, we do want to end in radians. So we convert back into radians, and that is our pi over 6. All right, so different functions are going to be positive in different quadrants. This is that acronym, All Students Take Calculus, or Amanda Spina Tortures Children, however you learned it. This is where we've got our four different quadrants here. In this first quadrant, all the functions are going to be positive. In the second quadrant here, this is going to be sine is positive, and also the reciprocal of sine. So that's going to be our cosecant is also positive. So when we do our all students take calculus, this is the oops, I wanted to highlight that, not erase it, AS, or Amanda Spina, but it also does include the reciprocal cosecant. Down here in the third quadrant, we have the tortures, or if we're doing all students take calculus, is our T tangent, and its reciprocal cotangent. Those are positive. And then the last quadrant here, our fourth quadrant, that's going to be our cosine, and then its reciprocal secant. These are the ones that are positive in the fourth quadrant. So when we reference this, we just usually talk about the original trig functions. So sine, tangent, and cosine. But if sine is positive, then it's reciprocal. Well, if we just flip the fraction, it still is positive. Same with tangent and the cotangent, and then cosine and secant. So all students take calculus. Remember, we start in that first quadrant and we move in that counterclockwise direction like this. All students take calculus. Amanda Spina Tortures Children. Whichever one helps you remember which functions are positive in which quadrants. So, using that to help us, we're going to do what we did yesterday. We're going to take this this coordinate point that we have here, -5, -12, and what we're going to do is we're going to draw in the angle in standard position that goes through that point, and we're going to try and figure out our 6 trig functions. So this is very similar to when we were given our triangle, except we're given information about our triangle, but just not exactly what our triangle is yet. But we can draw in that point. So that -5, -12 point is like down here. We don't have to be exact. We can get some idea. And I can connect that there. And this is the terminal side of my angle. So this is my angle all the way here in blue. But just like we did before, we want a reference triangle. We want to be able to create this right triangle here. If this is the coordinate point -5, -12, that x coordinate there is going to tell me what this horizontal distance is here. That horizontal distance that's in yellow, that's got a length of 5, but it's to the left, so it's -5. That red vertical distance has a length of 12, but it's negative. It goes down to -12, so that has a side marking of -12. What we want to do is we want to figure out what that hypotenuse is. When we do our 6 trig functions, we need to know our hypotenuse because we need to know for sine and cosine, and then thus for cosecant and secant, what the hypotenuse is. So we can do our Pythagorean theorem. And when we do this, we want to be careful with those negatives. It is -5 in parentheses being squared plus -12 in parentheses being squared equals c squared. When we get the numbers that we squared, after we square them, we want those numbers to be positive. So if the negative is in the parentheses, that means it's -5 times -5, which gives me positive 25. In your calculator, if you don't include those parentheses, what your calculator does is it's going to square the 5, get 25, and then make it negative. And so the parentheses tell me I want to make it negative first and then do my squaring. And so we want to make sure that both of those numbers, after we square them, are positive. And we should get that our c value, after we take the square root of 169, is 13. Remember, our hypotenuses are always going to be positive. Even if your legs are negative, the hypotenuse is positive. So I can finish off that hypotenuse, and my whatever this angle is, and whatever my reference angle is, I now know all 3 sides of that right triangle. So what we can do is we can use the ratios for our 6 trig functions and write what they are. So this whole angle in blue is theta, but using the reference angle and the reference triangle, I can say that sine of theta is -12 over 13. And because we're in the 3rd quadrant, it should make sense that sine is negative. Remember, it's all students take calculus. In the 3rd quadrant, it is tangent and it's reciprocal that are positive. Well, everything else is negative. So that means cosine should also be negative. Cosine of theta is going to be the adjacent -5 over the hypotenuse of 13. Tangent is the one that should be positive. Tangent is opposite over adjacent, so this is going to be -12 over -5, and negative over negative does become a positive. So we get the positive 12 over 5, and that would be the simplified form we want to keep. All right, last 3 are just our reciprocal functions. So sine, the reciprocal of sine is cosecant. So cosecant theta, I'm going to take that sine fraction and flip it upside down. So I get 13 over -12, which you can leave that way or you can put the negative out in front. Either of those is acceptable. Secant is the reciprocal of our cosine. So just like above, flip that fraction, get 13 over -5. Leave it that way, or I can pull the negative all the way out of that fraction. Since sine is negative, cosecant should also be negative. Since cosine is negative, secant should also be negative, but tangent was positive, so cotangent should be positive as well. And so that's going to just be our positive 5 over 12. All right, so very similar to what we were doing yesterday, except this time we're building the triangle from a little bit less information, but we still get to the same things at the very end. All right, so we already know that the sine of -2 tan is -1/2. We did that in our calculators. Now we want to do it without our calculator. And so we're going to draw in our reference triangles. Sorry, we did sine of positive 210. We're going to do sine of negative 210 this time. So we're going to start by drawing in that standard position angle. So negative means we open up in the clockwise direction. So I'm going to throw my -90 at the bottom, -180, -270, and I know I'm going to be in the second quadrant because -210 is between -180 and -270. And once again, it is closer to the -180, so it's going to look something like this. This entire angle here is my -210 degrees, but I want to draw in a reference triangle. So I am going to drop in that vertical line. And I want to figure out what the distance difference is here. So I can subtract my -210 and my -180. And so if I do like -180 minus -210, that'll give me +30. So that means this is a 30-degree angle inside the triangle. So I have a reference triangle with a reference angle of 30 degrees. And what I want to do is I want to fill in the side lengths. So 30, 60, 90 triangles, across from the 30 is a 1. And because that is above the x-axis, because that is moving in the up direction, that's going to be positive. Hypotenuse is 2. And then this last leg down here, that's going to be that √3. But because that is to the left of the origin, it's -√3. So just like before, we now have all the side lengths of our triangles, so we can do our trig functions. Now, the simplification here is going to be a little bit more involved because we have that √3 there. However, we can do it. We maybe have to do a little rationalizing. If you remember the 30, sine of 30, cosine of 30, and tangent of 30 from that chart we did yesterday, you can use that as well. Just remembering that everything except for sine, and sine's reciprocal, so cosecant need to be negative because we're in the second quadrant here. So this is sine. Sine is positive. It's reciprocal, cosecant is positive, but everything else is going to be negative. So you can use that to help you as well. I'm going to go through and do our ratios. So sine of -210, I know my angle now. This is going to be a positive value. Oh, I'm sorry. We're only doing sine. We're not doing all of them. That's going to take a little bit less time, so that's great. Sine of -210. We know it's going to be positive because we're in the second quadrant. Its opposite, the 30, is 1. The hypotenuse is 2. So sine of -210 is 1/2. You could check it in your calculator. You should get 0.5. We could go now and find the cosine, the tangent, and all the other ones, but we're not going to. All right, so quick little check. Reference triangles are always drawn to which axis? Do you guys remember? It should always be drawn to the x-axis. We're always going to draw in the vertical leg every single time. All right, so that one leg should always go along the x-axis, and we're going to draw in the other vertical leg every single time. So our triangles are going to look like this, or they can look like this. We're going to sort of get, like if I combine them all, like a bow tie looking shape. Oops. I shouldn't. You want to do it this way. There we go. There's my bow tie looking shape. Whew. So all of our triangles are going to be drawn down to that x-axis. Not to the y-axis, but to the x-axis. All right. So using those things, using our new constraints here to help us figure out which quadrant we're in, we're going to find all 6 trig functions. All right, so that all students take calculus, I'm going to put that up here in the corner so I can keep that in my mind. All students take calculus. I know my tangent needs to be positive. So if tangent is positive, that's going to put me in either the first quadrant, where everything is positive, or the third quadrant. So what I'm going to do is I'm going to look at my cosine now. This information, this angle, or this trig function we have given, this cosine of theta, that one is negative. If cosine is going to be negative, I cannot be in the first quadrant, because the first quadrant is all the signs, all the trig functions are positive. If cosine is negative, that means I'm either going to be in the second or the third quadrant. Because in the first and in the fourth, cosine's positive. So cosine is negative in the second or the third. So if cosine is negative in second and 2 and 3, tangent is positive in 1 and 3, that means I have to be in the third quadrant. So I don't know what my angle is, but I know I'm in the third quadrant. So when I draw this, my triangle is going to be drawn something like this. I don't know what my angle is. I don't know if I'm closer to the x-axis or closer to the y-axis, but I know that I'm in the third quadrant. And so what I can do is I can fill in my values. Remember, cosine is adjacent over hypotenuse. So that 4 is going to be the adjacent and the 5 is the hypotenuse. Remember, your hypotenuse is also always positive. So this is going to be a positive 5, and the negative is going to go with that adjacent side. So what I want to do is I just want to figure out what my last leg is, and I can use Pythagorean theorem for that. And just like before, you want to be careful with those parentheses. It is negative 4 squared plus y squared equals 5 squared. Making sure that negative is in parentheses. I get 16 plus y squared equals 25. So y squared equals 9. And then y has to equal 3. And once I've finished the triangle, now I just go and I make my list. All right, well, sine of theta, that is opposite over hypotenuse. So my theta, same thing as that reference triangle there, that's going to be the opposite side is 3. The hypotenuse is 5. We already know cosine. I'm just going to put it in my list so I have the full list here. That's the negative 4/5. And then tangent is opposite over adjacent, so that's going to be 3 over negative 4. We can do all of our reciprocal functions as well. Cosecant, we're going to take that sign and flip it upside down, so we're going to get 5 over 3. Secant, we flip the cosine, so we get negative 5 over 4. That 4 could go in the bottom. It can stay with the 4. The negative can go with the negative. The negative can stay with the 4 and go on the denominator, or it can move up to the 5. In fractions, if it's just 2 numbers, that negative can float back and forth, and whichever one is more convenient. And then same thing with that cotangent of theta. This would be like negative 4 over 3. We flip that fraction. All right. Same idea here. I want you to try this. First thing you need to do is figure out which quadrant you're in. So you're going to use that all students take calculus or Amanda Speen and Tortures Children, whichever one you want. And let me know. Whichever one you like, doesn't matter. But first you need to figure out using the fact that cosecant is positive and cotangent is negative, which quadrant we're in. Remember, if cosecant is positive, that means sine was positive. And if cotangent is negative, that means tangent is negative. So using those, try and figure it out, draw it in, and then list out all 6 values. All right, here, if sine is positive, that's either going to be the first or second quadrant. But if cotangent is negative, that means tangent is negative, and that's going to occur in the second and fourth quadrant. So that means I have to be in the second quadrant, in quadrant 2. So drawing in my triangle again, I don't know if I'm closer to the x or the y-axis, so it doesn't really matter. I just want to get some triangle in there. And if sine is 1 over 4, that's the opposite side over the hypotenuse. So my opposite side is 1. My hypotenuse is 4. And using Pythagorean theorem, I get that that missing side is root 15. But because that's going to the left of the origin, it is negative. It is negative root 15. So we can go and using our ratios, write them all out. So sine we already knew was 1 over 4. Cosine is negative root 15 over 4. And then tangent was 1 over negative root 15. Square root's in the denominator, so we need to rationalize that. So multiplying top and bottom by the square root of 15, we get root 15 over negative 15. Our reciprocal functions, just take the original ones and flip them upside down. So cosecant theta, that's 4. Secant theta would be negative 4 over root 15. I do need to rationalize that. So I multiply top and bottom by root 15, and I get negative 4 square root 15 over 15. And then that last one, cotangent of theta, is going to be negative root 15. When I do this, I don't actually want to take that last answer for tangent and flip it. I want to take this initial one and flip that, because that's going to save me a little bit of extra time in rationalizing. Hopefully you got those. If you have questions, please let me know. What we're going to do is we're going to, without a calculator, try and do these exact same things. We're going to use our reference angles to find sine, cosine, and tangent. We won't do the other 3, the cosecant, secant, and cotangent, but exactly what we were doing before. In part B, notice that our angle is 585. That is more than a full revolution. So you're going to draw it like normal and then still get that reference angle. And then that 10 pi over 3, you have a couple options. You can do this in radians. That is going to be more than 1 full revolution. Or you can convert to degrees, in which case we would see that it's more than 360. So go ahead and do those. We just want sine, cosine, and tangent. We want exact values, so we want to draw those reference angles, reference triangles, and use our ratios. All right, so here is a lot of work, a lot of answers, but you want to first figure out draw on that angle, figure out what quadrant we're in, find your reference angle. So for negative 210, that reference angle would be 30 in the second quadrant. And then setting up those triangles, it's 30, 60, 90. Across from the 30 is a 1. Hypotenuse is 2. Adjacent to 30 is root 3, but because it is in the left direction, that is a negative root 3. So setting up those ratios, we get what we have off to the right there. For 585, that is more than 1 revolution. That is 225 degrees more than 1 revolution. So that puts us all the way into the third quadrant after going all the way around. And we have a reference angle of 45. So my 2 legs are both 1, but because they are to the left of the origin and below the origin, both the horizontal and vertical legs are negative. Hypotenuse is still positive, and that's our positive root 2. So for sine and cosine, I do need to do some rationalizing, and they become negative root 2 over 2 for both sine of 585 and cosine of 585. Whereas tangent is negative 1 over 1, which reduces, the negative ones cancel, and we get a positive 1. For number C, if you would like it, I think most of you prefer this to convert the 10 pi over 3 into degrees. You can do that and get 600 degrees. And you can draw in that full revolution plus another 240. And so that puts us into the third quadrant again with a reference angle of 60. So both those legs are still negative, but this time it's a -1 and a -√3. That -√3 is across from the 60 with that positive hypotenuse of 2. And so using my ratios, my SOHCAHTOA to help me, we get what we have there, -√3/2 for sine, -1/2 for cosine, and positive √3. No rationalizing needed, just a little negative work in the tangent there. If you have any questions on any of that, please come talk to me and we can work through it together. All right, just a couple more to do. Go ahead and do this one. Take a second, try and figure it out. We've got tangent. We know tangent, so we know our opposite and our adjacent. And then I know that it's negative, so that's going to put me in either the second or fourth quadrant. But I have that extra constriction that cosine is positive. So cosine is positive in the first and fourth. So that should hopefully help you. Draw in your triangle, find the missing side using Pythagorean theorem, and then write what sine and what secant of that angle are. No need to find the actual angle. We're just trying to figure out what sine and secant are. All right, so tangent's negative in second and fourth. Cosine is positive in 1 and 4, so that means I have to be in the fourth quadrant. So again, don't really care if I'm closer to either axis, but I can draw in and I can mark up my opposite and my adjacent. Remember, tangent of my theta is the opposite over the adjacent. So that opposite side is the -5, which makes sense because that's below my x-axis, is vertically going down. And my adjacent side is +4, and hopefully that makes sense because we're moving in the right direction towards the right-hand side. So we're moving in the positive direction. So we need to figure out our hypotenuse. So a squared plus b squared equals c squared. Remember, we want to put the -5 in parentheses and then square it. So we get a +25. And we get that c is the square root of 41. That doesn't reduce, so we don't need to build a tree or anything like that. 41 is prime. So using our ratio, sine of theta is opposite over hypotenuse. I get -5 over square root of 41. I do need to rationalize that. So we get a -5 root 41 divided by 41. Now this secant of theta is a little bit trickier because we didn't find its reciprocal. We didn't find cosine. So I want to think about, okay, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So that means secant needs to be hypotenuse over adjacent. So my secant is going to be root 41 over 4. And I don't need to do any rationalizing because that square root is already in the numerator. All right, last one, just like we did before. This time we know what secant is. So you want to think about what's the ratio for secant. What's secant connected to? It's 1 over sine. So if sine is opposite over hypotenuse, that means secant needs to be hypotenuse over opposite. And that's negative. And if secant's negative, sine is negative. So we think about where sine is negative, and then we want tangent to be positive. So go ahead, do what we just did in number 10 here in number 11, and then come back and check your work. All right. So just like before, secant is 1 over cosine. So that's going to be our hypotenuse over the adjacent. Cosine is going to be negative in the second and third quadrant. Tangent is positive in, in the first and third. So we're going to be in our third quadrant. And I can draw in that the hypotenuse is 17 and my adjacent side is -15. Now I know it looks like from the fraction that the hypotenuse, the 17 should be negative. But remember, your hypotenuse is always the positive. And then that horizontal leg, remember we're going in the left direction, that one should be the negative. So it should be the -15. Doing Pythagorean theorem, we get our missing side is 8, but we're going in the negative direction. We're going down, so it's going to be -8 on our triangle. So sine of theta is going to be -8 over 17. And then cotangent is 1 over tangent, so it's going to be adjacent over opposite. That's going to be -15 over -8, which does simplify to 15 over 8. So I misspoke earlier. We do have 4 more, but these should be very, very fast for you. We're just going to use our calculator. We're going to evaluate these. Make sure you're careful on your mode. A and B are both degrees. And the way I know this for sure is because it's got the little degree symbol. In C and D, it is radians. I know D tends to be a little more obvious that it's radians because it has the pi. But C is also radians. And the way I know this is because it does not have the degree symbol. So if it is going to be a degree value, it will always have the degree symbol in there. So A and B are degrees, C and D are radians. Go ahead and do this really fast on your calculator, and we will double check in just a second. All right, so for the cotangent, cosecant, and secant, those are reciprocal functions. So we do need to do 1 over the reciprocal function. So it's 1 over tangent of 410. And so we get 0.839. 1 over sine negative 195 is 3.864. C and D, you do need to change the mode on your calculator to be radian mode. And we should get negative 0.657 for sine of negative 7. And then secant of pi over 9, that's 1 over cosine pi over 9. So you just do pi divided by 9 in that parentheses, and you get 1.064. Hopefully this made sense. Hopefully it was starting to come back to you, the things that you did last year. If you have any questions, please don't hesitate to let me know.